Hello, this is an industrial control circuit troubleshooting tool 6 module. Now we are doing extra skill test number 7. The work order that we received stated that the system is malfunctioned. It did not operate as expected. So what's wrong? Let's dive in. By looking at the control panel, we found that the alarm lighting is on, showing that there is some issue whether the temperature is more than 90 degrees Celsius or the water level more than 90% or the overload relay is tripped. By looking at the power panel, we notice that the OL1 thermal overload relay for the MC or agitator contactor is actually tripped. You can see the overload relay button popping up, meaning it is tripped. So overload can be classified as either electrical overload, mechanical overload, or process overload. Okay, electrical overload means it is single phasing. One phase is open. Mechanical overload can be due to the pump impeller or the motor bearing is seized or jammed. Process overload can be due to the upstream downstream valve is closed or shut during process. First, we try to check the electrical overload by measuring the current. We can put the tom meter, the ammeter tom at the outlet of the overload relay to measure the current. Now we reset the overload relay. Then we try to run the process one more time. Before we run the process, we drain the liquid from the vessel. And then we start the process. Zero ampere, 20.1, which is an overload current. And we try to reset the overload button and measure the current again. Here, 0 ampere. So all 0 ampere. Oh, sorry, there's a 0 ampere here. So most likely it's a single phasing occur at this line, first line. Okay, we can measure the AC voltage to check whether the fuse is blown or not. Okay, there's no voltage here. That means the fuse is blown. So we have to change the fuse. Before that, we need to cut off the power supply and perform the lockout takeout, verify the lockout takeout is done properly. Then we change the fuse. Okay, as we know, the fuse blows because of short circuit. It can be due to a fault, it can be due to device internally short circuit. In this case, for the motor, it can be due to motor winding to winding short. Okay, so we should measure the resistance here. Okay, by opening one end. Okay, now this line is okay. We have to measure the line to line resistance to make sure everything is okay. 12.4, 12.4, it looks like okay, but hold on, we have to check the earth fault. By checking the earth fault, we should get open circuit, not resistance reading. This shows that there is an earth fault inside the motor. This is an agitator motor. So most likely the motor winding is burned. Okay, perform inspection. Motor has some burnt winding insulation, so the exposed wire actually touching the metallic frame of the housing and cause the earth fault. Okay, so we replace the motor. Then normalize all the wiring connection and normalize the multimeter, remove the lockout takeout, and run the process one more time. So now you see the agitator able to run, so the process should be okay. Okay, pass.